Now that everything's pretty much going to EFI, we have a lot of questions on it at starting line, and it seems like because we're all being forced to become educated on it, whether or not we want to or not, whether we want to maintain our own sleds, whether or not we want to be able to tune them, we got to have that basic knowledge, and if we want to tune them, we probably got to have a little more advanced knowledge. So that's what we're going to talk about today. Now, the tricky part here is we might have some advanced tuners here, we may have some beginner tuners, and so it's a little bit tough to try to incorporate it all into one seminar. So those of you that are advanced, bear with us a little bit while we cover the basic stuff, and then we'll try to get into some advanced stuff in the end. So we'll start off with the basic history of fuel injection. Fuel injection was basically developed in Europe by Bosch. It started in the early 40s, and it was a mechanical version. There was really no electronics at that time that were helping control it at all. It was all just done by mechanical devices and pressure. It was used mainly in Europe because they had a fuel crisis long before we did in the 70s, and so the governments over there pretty much forced them to do it. They used a lot of 4 cylinders. Later on, they started using turbocharged 4 cylinders, but they were fuel injected, almost from the beginning. In the 70s, the U.S. kind of started to adapt it into the automotive industry. Cadillac was, I think, the first OEM to use it on an automobile, and then the power sports industry started using it in the 90s. Of course, diesels have had fuel injection for years and years, but they were a mechanical version. So as far as electronic fuel injection, the power sports, you guys probably remember some of the old 580 Cats and some of the Indy 500s that had, in the RXLs that had, those systems were not really like the system we're using now. They were kind of more of an EEPROM system that was not nearly as advanced as what we're using now. EFI, why have you seen it all of a sudden come into snowmobiling the last 3 or 4 years? 3 reasons. Control and accuracy. It's so much easier to control the fuel with an injector. We can pretty much tell the injector to squirt as much fuel as we want or as little fuel anywhere in the RPM, anywhere in the throttle position range. It doesn't matter. We have complete control over it. Where with a carbureted version, it's totally relevant to vacuum. No matter how mechanical you can get with the carburetor as far as needle adjustment, main adjustment, pilot adjustment, it still depends on vacuum. So it still depends on throttle position to a point. So we can be so much more accurate and have so much more infinite amount of adjustment with electronic fuel injection. But the reason that we're really seeing it is because of emissions. The EPA is mandated very specific hydrocarbon outputs, and they've been updating it about every 2 to 3 years. And the OEMs they can't produce the machine. It can't even go to production until they meet that standard, and it's a fairly lengthy test process. Most of the OEMs keep a government member from the EPA on staff at all times, and they watch that process year-round. And so as those EPA regulations have become strengthened and become more strict, the OEMs have had to increase that technology, or that's what's placed the demand for more technology and what we're seeing with EFI. And then the third thing is cost. Some of the electronic components can be manufactured for virtually almost nothing. Some of them aren't so, but it seems like the more we see it, the cheaper they can manufacture it, just strictly because of volume. 3 major functions. It's no different than a carburetor. You still have to control the air, you still have to control the fuel, and you still have to control the spark. And electronic fuel injection still has those same 3 functions. We'll talk about air. They're using a throttle body, which is basically just like a carburetor, only we're using a butterfly valve instead of a slide. There are a couple of fuel injection systems that do use a slide, but pretty much everybody's using a butterfly valve, and the reason being is because they have to be able to sense what the throttle position is. If you're at idle, that would be 0%. If you're at wide open throttle, that would be 100%. And everywhere in between, they can do that with a rod that runs through the center and a sensor on the end. You'll see that black box on the end. Right here, that's the throttle positioning sensor. Through the center, from the outside of this TPS all the way through, is a rod. Well, actually, there's a rod that goes through here and a rod that goes through here, and then they're connected up here, so they can calibrate or synchronize the throttle bodies. So that rod, when it's turned, this sensor can measure the amount and send a certain voltage back to the ECU saying, hey, we got more voltage or less voltage, so the throttle position is being raised or lowered. And that's why they use a butterfly instead of a slide in most cases. The next is the electronic control module. Some people call them an electronic control unit, or ECM, or ECU. What that is it's the computer or the brains of the system. It's what gives all the commands on what all the functions of the system should be doing, but it's also what's receiving all the information from the sensors, calculating it, and then giving the command. One really neat thing about these ECUs is the Skidoo ECU, the Bombardier, on the new E-Techs has fuel going into it to cool it. You'll see this input right here, that's for a fuel line to go in. There's another one on the back side that lets the fuel come out. They run the fuel from the fuel tank, from the pump, through the ECU, and then to the injectors. So they're cooling the ECU with fuel, which is a pretty neat deal. Next component is the actual injectors themselves. And the Polaris and Arctic Cat use a very similar injector. What a lot of people don't understand about injectors in the snowmobile industry is there's Arctic Cat and Polaris use 3 different types of injectors on every machine. And the reason they do that is because of manufacturing costs. In order for a manufacturer to manufacture a injector that's a very specific flow rate, it's fairly expensive. It takes some very specialized equipment to do it. So what they do is they make these injectors in batches, and they rate them according to flow, and they have to flow within about 1.5%, but they'll take the bottom 3%, the middle 3%, and then the top 3%, or something around that area, and they'll put them in those batches. And then they'll give them a code to signify what the flow is, if it's a high flow, a medium flow, or a low flow. Polaris uses color. See these yellow bands right here? Those are what they call yellow injectors. They also have a red and a blue. Arctic Cat uses shapes. This is a square. They also have a circle and a triangle. Now, I don't know off the top of my head which one's a higher flow and which one's a lower flow, but actually on Polaris, yellow is medium, and I think on Arctic Cat, square is medium. You're going to see more mediums, you're going to see more squares and yellows than anything because of numbers they're shooting. That's what they're shooting for in the manufacturing process. So to compensate for that, they use maps, they write fuel maps that offset whatever the injector is. So in order to make them all come out of the factory the same, they'll put a higher flowing injector with a map that's 2/3% less fuel flow, or vice versa. Does that make sense? So a lower flowing injector will get a map that's 2/3 higher fuel flow, and then of course the medium injector will just get the base map. So that no matter what sled you get, what machine you buy, in the end, the fuel delivery, they're all going to be the same. Even if you have an injector that flows 1/3 higher or 1/3 lower, they'll compensate that with the map. We all follow that? Okay. Now Skidoo is a little bit different story. At least on the E-Tech, they did have what they called the SDI early on, which was more similar to these injectors here. They were injecting into the case, kind of like Polaris does right now. But on their new E-Tech, this is a completely revolutionary new system. The system was originally developed by OMC, which was then transferred to Johnson and then Evinrude, and now they've adapted it into the snowmobile industry. It's extremely efficient. As far as emissions, in some of the emissions, they're 80% cleaner than a standard fuel injection system, which is, cleaner than a 4-stroke, literally. And that's why Skidoo is pushing this technology. Not only is it cleaner emissions-wise, it's also has less fuel consumption. So those guys that are riding back east that are trying to get 90, 100 miles out of a tank, a lot of times the E-Tech will go a little further because they have less fuel consumption. But the way this injector works is it's a voice coil activated injector. You'll see these coils right here on the side. Those are the voice coils. And they have a cylinder in the middle that acts like a speaker. So a speaker is basically a harmonic frequency tuned into a voice coil that makes the speaker move and creates a harmonic sound. They're basically doing the same thing here. This chamber then moves and pressurizes a diaphragm right here. The fuel is running all the way through. You've got a fuel inlet right here and a fuel outlet. So the fuel comes in, runs down here and fills in this chamber. When the voice coil activates, it pressurizes the diaphragm, pushing the fuel through the injector. It is not a mechanical injector. It's activated by hydraulics. So the plunger is activated by fuel pressure itself. Whereas in the previous version that we looked at, those are actually a mechanical injector. There's a rod that opens and closes a valve in the very tip of the injector. So those are very, very different systems. And the injector is quite large. That's the cylinder head. There's the spark plug. You can see the size of the injector. But because they're running so much fuel, they try to keep the system very cool. The fuel does cool the system quite well, where these systems can heat up if they're overused, if duty cycles pushed past 90% for a long period of time. Duty cycle. Let's talk about duty cycle for a minute. You want to cover that?
Sure.
Okay.
So duty cycle is really easy. If you guys think about injectors, they turn on and they turn off. How long they turn on determines how much fuel is delivered. So the duty cycle is basically the percentage of time that the injector is on. So for example, a 50% duty cycle means that the injector is running 50% of the time. It is squirting fuel 50% of the time. So obviously, if you have a duty cycle that's 100%, that means that that injector is just on. It's like a garden hose just squirting fuel. So obviously that's going to deliver more fuel, but that's also going to build up heat. So that's why Dustin was saying, typically when you're running setups, you want to shoot for duty cycles that are a little lower than that to keep the heat down. So that's also really important when you're doing a turbo application. Is when you're running a setup, you might be running lean and you might feel the sled hiccup, and but you're adding fuel with whatever fuel device you have, a boondocker, a power commander, or whatever. Well, one thing you need to look at is your duty cycle, because if you're at 100% duty cycle, which means the injector is on all the time, and you're not getting enough fuel to the motor, well, that tells you right there that you need to bump up either your fuel pump or just increase your fuel pressure somehow, or go to bigger injectors so that you don't have to use as much duty cycle. So that's basically what duty cycle is. So if you hear guys talking about, that's what they're talking about.
So an easy way to understand when he talks about time, if it's open 50% of the time, the injector only has so much time from where the piston comes up to top dead center. So you've got to think about it in piston travel. The duty cycle is basically how much time that injector has to squirt with the allotment that the piston is giving it before it covers up the intake port on a two-stroke. So that every engine's different. When we're talking about the E-Tech, that's critical, because one of the reasons that they're getting them so clean is they're not squirting until after the piston has covered the exhaust port. Which that means the amount of time that the injector has to actually squirt the fuel is significantly less, by a lot. So these types of motors don't have nearly the amount of duty cycle or the allotted of time to squirt the fuel that, say, this type of injector has, because they can squirt the fuel much, much earlier. If they're squirting it in the intake port, they can squirt the fuel before the piston is covered the exhaust port. Where if they're using like a cat style where they're squirting the fuel into the throttle body, they can squirt it pretty much whenever they want. As long as the piston is creating vacuum on the case, they can start squirting fuel into the intake airstream. So does that all make sense, the difference between those three types? Okay. Let's move on to how we get our power to run the fuel injection system. Carburetors, obviously, we still use a stator. We've got an Articat system here, and we've got a Polaris. And then the injectors need to know when to fire. There's got to be something that gives them a signal saying